Hey YouTube, so you've seen my how-to with context-free, and you've probably seen my final animation results with my context-free and processing work put together. So this is how I managed to put the two programming languages into a single project and generate animations like this one. Here's my processing code that I use to generate context-free code that I use to finally generate the images used in the animations that you saw. There's no real easy way to go over code other than to start at the top and work our way down, but this isn't as complex as it looks. It's only a single for loop. The rest of it is just kind of finding loopholes and filling them with more variables and little fixes in order to make this do what I wanted it to do. At the top we have a variable that tells us how many frames we want the animation to be. This is just the number of steps that the program will run, generating new instances of context-free code, which will be saved to new files, which will then be rendered into new images. I have this array called step math, which is used on every step of the animation to generate new values for variables that will be used in the context-free code. So every frame of animation has its own unique context-free file which is used to generate a new image. So instead of having a static context-free shape which renders differently over time, which is how the built-in context-free animation tool works, my animations have different values in the code, or effectively values in the code that change over time instead of being static. I use this variable called rel time in order to do that. Rel time is actually the number of the current frame number divided by the total number of frames. So if I have an animation that's 10 frames long, then on frame 0 the value of rel time will be 0, and on frame 10 the value of rel time will be 1. It doesn't matter whether it's 100 frames or 1,000 frames or just 1 frame. You will get a 0 to 1 progression of that rel time, which means that no matter how many frames you use, the movement of your final animation will be the same. This is really helpful if you want to test something and you're not sure how it's gonna finish and end. Instead of rendering 1,000 frames and watching the entire thing fail, you can set it down to 10 frames and look at it like a flip book. You see just little snapshots of it. Next I have a bunch of strings used for the output of this program. The CFDG name, which is used for storing the sequentially numbered file names that the code will go in. This string array, which only has one entry in it, CFDG code, that's where I store the actual code that we put into the file with the file name CFDG name. It has to be in an array because processing's string out or save string function requires that you use a string array. So I've just used an array with one entry. Step number is used for storing a 5-digit number, which will be used to make all the output files sequentially numbered. If I were to just use the frame number, there would be no leading zeros, which means when I go to finally try to assemble these into an animation, it won't work. I use virtual dub, and when you open the first image of a bunch of sequentially numbered images, virtual dub will import them all as a video. But if they don't have the leading zeros, it'll only import the first 10 from 0 to 9 and then stop, because there's no leading zeros and the numbers don't line up right as far as virtual dub is concerned. I have this 2bat, which is the contents, or it will hold the contents of a batch file, which is used to run Windows command line instructions for rendering each frame of the animation. This array has to have as many entries as there are steps, because each file has a different name. So the batch file has to have a new line for each file it's going to render. And finally, a string that holds the path and name of the batch file, which is used to render the whole mess. That's static because it's always the same, just render.bat. This next section here is used to hold static values for the variables that will be used in the context-free code. In this case, I'm using that same rings context-free file. So I have a first rotation, X move, second rotation, all that. And I'm storing some default values. So the static values you see here, or something similar, up here in the first section of the code. I store them here because I will be modifying them later on, but if for some reason I want to leave one alone and have it not move, I can always comment out my later assignment, and then these values will just already be assigned, so I don't have to remove long sections of code and go back and forth when I'm testing things. So we get into the main loop of the program, which runs until we get to the number of frames of the program. Each loop each pass through the loop generates a new context-free file, which is used for a new step or frame in the animation. Here that rel time is generated. This just gives us from 0 to 1 over the length of the animation. And here we get into the step math. And the step math is something I had to test in another processing file over here, where I have just a very pared down version of this. And what I can do is test the basically test the shape of what I'm going to get from each function I'm using to assign values into the context-free program. So if I look at step math 1, I have the rel time times 20, which means it will start on frame 0 as a value of 0, and at the last frame, in this case there are 800 frames, at the last frame this term will be valued as 20 because it will be rel time 1 times 20, and I have a offset of 20 as well. So when I run this, we'll see a straight line starting at 20 and ending at 40. This lets me test where I want to have the start points and end points of more complex terms. If I want to have something like in this step math number 3, I'm using the sine of rel time. This 6.28 changes rel time when it goes from 0 to 1. Multiplying by 6.28 makes it a 0 to 360 degree for as far as the trigonometry is concerned, because processing uses radians. Times 10 means that it will do 10 cycles throughout the animation, and the last times 10 will give the sine wave an amplitude of 10. So when we run that, we have 10 cycles of a 10 pixel tall sine wave here. If I were to change that 10 inside just to 1, or I guess remove it completely, then you'd have a single sine wave of height 10 that takes the entire 800 steps. If I were to change this to 400 steps, because I'm using that rel time, you'll see that the sine wave still takes the entire 400 steps. It looks more compressed, but if this was an animation, it would still take the entire animation to do a full cycle. So back to my context free, we can show an example of what these variables look like. Let's take a look at the step math 0 because it's an easy one. When we run it, we'll see that it goes through 10 steps from 110 to 130 because rel time is multiplied by 20. Moving down, we have the area where we actually assign these step math values to a string, which is used in the assembly of the final context-free code. I have to use a string because I'm adding multiple or appending multiple strings together before I can finally write them into a context-free file. So here, all of these are commented out, which means the above values, these default values, will be used in the context-free code. So if I were to render this now, which I've already done, and then generate the image files, you can see that as I cycle through them, they don't move because I'm using these static values. I haven't changed them in any way using the step math. So let's take the comments out on first rotation. We'll run it again, and it's generated some more context-free files for us. We'll render those over top of the last ones, and we'll see that as we cycle through the images, there's now some animation because each of the context-free files here generated has a slightly different value for that first rotation. Taking a look at it here, the first one is 110, the sixth one in 122. So we can see that each step now has a different value, allowing us to render them sequentially and end up with an animation. So let's just enable all of these and move to the next section. Here I'm generating a 5-digit number which is used for sequentially numbering the file names. And the reason I use those 5-digit numbers is to satisfy virtual dub so that when everything gets imported it works. If you look here, you can see that they all have leading zeros on them, so everything lines up nicely. It just makes things a little bit easier. And finally, this monstrous string, which actually holds our context-free code. Let's take a quick look at our original code here, where we have the first rotation is 120, x move is 1, and so on. When we look here, we have the first rotation, but then I've added another set of quotations, and I'm actually appending the value of the processing variable that is named first rotation. So whatever is calculated in the step math is assigned to this first rotation as a string, and that string is appended in the middle of the original context-free code. This is all in one string because I've removed all the line breaks. If you put a enter in it, everything goes wrong. You have to keep it all in one line. But if you follow through, you'll see all I've done is add at the top, appended in the processing values for X move, second rotation, and so on to the context-free variable of the same name. So when they get used farther down inside the context-free program, they are assigned the values that we've calculated inside processing. It sounds complicated, but after you do it a couple of times, it just gets easier and easier. As long as you use static variables at the top of your context-free program, you can import these easily. If you try and replace them in processing by replacing this with the extra set of quotes and appending in your processing variable, what will happen is in context-free files where you're using randomization, each generated image will be wildly different from the rest because the randomization is calculated in part using the contents of each shape. So by declaring everything at the top here, you make sure that images that have randomization to them have the same randomization from step to step. So after we've generated all our lines of context-free code, we save it to a string, or rather we save the string to a file. The file name is generated up here using that 5-digit step number, and the contents of the context-free code which we generated here both get saved. After that, we add a new entry to that 2-bat array, and the 2-bat array holds the command line, it holds the Windows command that will actually render the context-free files into images. So we have the path to the command line program. We have some of the switches, so 1280 by 720 image, and X gives us the lower limit for rendering a shape size, so 1/2 pixel. We tell it what we want to render, which is actually the same file name that we generated up here. And then finally we tell it to output to a file which I just call RF, followed by that 5-digit number .png. After the loop has made it all the way through to its last step, all of the contents of that 2-bat array get saved into the batch file whose name we picked up at the top, that render.bat. That gets used. It saves all the command line instructions to one file, and the program prints done. So let's run that again. Take a look in the folder, and we see we have our context-free files. If we look inside this batch file, you'll see here's all our command line instructions for rendering each image one at a time and assigning it a file name. We can render that file. And then we have our animation. If you open it up using Virtual Dub, it will import all of the images one at a time, which you can play back. At 10 frames, that's not particularly interesting. So let's bring it up to 200 frames so that we can get a better idea as to what all this step math is doing to our animation. And here we have our first look at a context-free animation generated using processing. So the rotation and displacements are all linear, but I'm using a sine wave to modulate the thickness of the rings, giving that cyclic kind of pulsing look. So it's a little bit of a complicated process, but when you go through it one step at a time and think about what you're doing, it wasn't too bad. I hope you found my animations interesting, and I hope you found this helpful. If you'd like to see more like this, check out my channel. Thanks for watching.